several times actually, that an equation is like a balance beam, where the equal sign is the middle, and everything that is on one side of the equation, or the equal sign, falls on the left-hand side, and everything that falls on the right side of the equal sign falls on the right-hand side. This is a little hands-on manipulative, where you actually take little boxes that have a, what do these boxes have on them down here at the bottom? It's got an X, right? And you've got little ones also. You can actually drag them and put them, like physically put them on the balance beam.
Can I solve it?
Okay, well hold on, we gotta set it up first. Before we even solve anything, we gotta set it up first and make sure we've got it set up correctly. So if the left-hand side of my equation says 4x plus 4, okay, and what we're gonna write on our paper
is 8x.
Thank you, ma'am. What we're gonna actually write on the paper is the equation, so we're going to write the actual equation itself on paper.
I have to combine 4x and 3x
Oh.
7x.
Wait.
4 plus 5 is 9.
I beg to differ, unfortunately. Now, if we were doing like terms like we were doing, ma'am, you would be spot on. We're not doing that anymore, and that's why this is confusing, and that is why, even though I know sometimes we don't like, the hands-on way, I feel like this way kind of makes sense. So let's just build a model of what it looks like first. So if the left side of my equal sign has 4 x's and a 4, what do you think I'm going to drag and drop over to the left side of that equation?
No 4.
4 what?
X.
4 x's, right? Because 4x literally means I have 4 x's. That's literally what it means. So I'm going to use my mouse, and I'm going to drag. I already got one. I'm going to drag a second one.
Oh, that'd be hard without a mouse.
I'm going to drag a third one. But look, I'm pulling it off just fine, right? And a fourth one. So I have 4 x's to correspond to my 4x. I also need a 1, a 2,
A 3 or 4.
a 3, and a 4, because that is the other piece of what I have on the left side of my equation. What am I going to put to the right? Because right now it's out of whack, because I put stuff on the left side. 3 x's. And how many ones?
3.
And
No, 5 ones.
5 ones, exactly. So 1, 2, 3, 4, and 5.
I don't think you have all numbers on there, so you can just put them.
They do make iPad apps that do that. They're balanced. Okay, that is literally what an equation means. It means that if you take 4 x's and 4 ones, in this particular case, and put it on one side of the equal sign, it's going to literally balance out with 3 x's plus 5 on the other side of the balance beam. So we're going to write this. Unfortunately, in real life, though, we're not going to get a balance beam very often, though, right? So we need to write the equation on paper too. So 4x plus 4 is equal to 3x plus 5. I know it's going. There's a little bit of a lag here. So we're going to do it both ways. I'm going to show you how to do it with the hands-on piece and without. Now, the reason, and I love that you brought it up, it's like you are, get into Google Classroom, ma'am, and I'll show you where we are. It's like you're reading my mind, De'Ara.
Which one are you going to do first? Hands-on or?
I'm going to do both of them at the same time. So y'all are going to help me with the hands-on, and we're going to write on paper. Okay? Now, we cannot put the 3 x's and the 4 x's together, because they are on completely opposite sides of the equal sign. So if they were together, you could just combine them, but they're not. One's on one side of the balance beam and one is on the other side. If I went and I dragged my x's from this side over to here, what would happen to my balance beam?
It will unbalance.
It's going to be unbalanced now. So that is why I can't just combine them, because they are on opposite sides of the equal sign. So instead what we got to do, but we've got to solve an equation, because the equation needs to have just one variable set equal to a number. So in other words, we got 2 sets of x's. So one of those sets of x's needs to go. So the cool thing about the hands-on, I can literally, as you can see, just reach on here and I can pull off those 3 x's. And that's exactly what I'm going to do. There's a little hidden trash can back here that you guys can't see. I'm literally going to grab the 3 x's that are on the balance beam, and I'm literally going to throw them in the trash. Okay? Because I can't, when I'm solving an equation, my goal is that I need to get just one set of x's. But what just happened to my equation? Now it's all jacked up.
It's unbalanced.
It's unbalanced. what could I do to put it back into balance? If I took 3 away from the right-hand side, what could I do to balance things out? That's exactly what I need to do. I'm going to literally, physically pull 3 x's from the left-hand side.
Told you minus 3x minus 3x.
So look what, so now ignore the fact that that 5 is just kind of floating in midair, but it's balanced, okay? So on paper, obviously what that would look like is I subtract, because what's the word? We took away 3 x's. What operation is that?
Subtraction.
That's subtraction. So what we just did on paper is we did minus 3x. Ignore my ugly 3. So that x got taken away. That x canceled out. And what do I still have left over there on the right-hand side of my equal sign? Still got a 5.
Oh.
Right? Yeah, that 5 is still there. The 5 hasn't gone anywhere. But this literally gives you a physical model to prove if I took 3 x's away from one side, why I had to take 3 x's away from the other side, because it kept it balanced. So exactly. So now on paper, we're also going to do minus 3x.
Equals 1x.
Is that really bad?
So here, this is what the model is good for. The model is good for you seeing, like, my equation is balanced. My balance beam is balanced. So I know I did my first step right. That's what this is good for. Okay? So if I took away 3 x's from one side, all I've got, so if I had 4 x's, I took away 3 x's. How many x's have I got left on the left-hand side now? I just got 1 x
Plus 4.
plus 4 is still there.
Equals 5.
Equals 5. Now, does that match up with my model? Do I have x plus 4 to match x plus 4? I sure do, because I got an x and I've got 4. And then I have 5 over on the right-hand side. So I can use the model to check my steps and make sure that I'm doing it correctly. Exactly the same way that you can subtract numbers from an equation, you can also subtract variables. I can literally just reach on there and pull off an x. Now we just got a little bait. Is our x isolated all the way yet?
Nope.
Nope, it's close. What's the other thing we got to get rid of in order to get...
We got to do minus 4.
Okay, so I'm literally going to reach onto my balance beam, and I'm going to yank those 4 off and drag them into the garbage. I'm literally just going to go 1. Oh, I'm not going to add it to that side.
Don't those 2 4's cancel out? 1x.
Okay, so I subtracted 4. My x is isolated now, but what do I have to do to pull it back into balance?
Add an x.
So I took 4 away from the left side. If I took,
4 away from the right.
I got to take away 4 from this side too. 2, 3, and 4.
So it's equal.
So now it's equal. Now my x is isolated. Now on paper, obviously, it looked like this, where I just subtracted 4.
Ain't 1x the same thing as x?
1x is the exact same thing as x. So I subtracted 4 from each side. So now my x is isolated, and I have my final solution of x is equal to 1. Some people love using the balance beam to help them check their work as they go, and some people feel like this is so stupid, this is juvenile, I can do it without it, so just let me do it without it, and that is fine by me. Okay? I needed it. I needed something hands-on and checking my steps for me when I was in your shoes, but that doesn't mean that you guys do. Okay? The only requirement is that you're getting ready to solve 10 equations. Okay? So let's say you're in the second boat. You hate doing it this way.
This is simple.
You don't have to actually drag and use the balance beam. See right here where you click on New Problem? You at least need to use this tool to give you the next problem. But if you just want to solve that problem on paper, you can just solve that problem on paper. If you can do it, fine by me. I'm not going to make you do a bunch of extra work and drag boxes if it doesn't help you. Because it's there to help you, not to give you more to do. So the expectation is I'm going to collect your paper. I want you to do just like we did here where we worked the problem out on paper. Okay, so I need to be able to see all of your steps, and I need you to do that for 9 more. We've done the first one together. So I want a total of 10. Okay, do we have any questions about what we should be doing right now?